2. Just a minute, it is giving thicker pen marker. Scattering matrix, first we will see the 2 by 2 port matrix. The 2 by 2 port matrix is represented with S11, S12, S21 and S22. This one. Yeah. First, we will discuss about today. We will discuss about the block 2. In block 2, we have is scattering matrix. Here, the scattering matrix. The main topics we will cover in the scattering matrix are what is the need of S parameters. Next, we will go for the scattering matrix formulation. Next, we will see the properties. What are the properties we can discuss of this S matrix? Next, we will go for the shunt element as well as series element in the scattering matrix. First, we will see the introduction of scattering matrix. This scattering matrix is also called as a block box, which it is represented with 2 by 2 matrix. Here the what is the 2 by 2 matrix we can represent? The 2 by 2 matrix is S11, S12, S21, S22. This is called 2 by 2 matrix here. The 2 by 2 matrix is S11, S12. The 2 by 2 matrix is S11, S12. Next, what is the next matrix we have? S21, S22. This is the basic matrix which we will use in this scattering matrix. Here, 1 is either, suppose I have S11. In this S11, also can represented as S of ij, ith element as well as jth element. This ith element is 1, jth element is 1. Suppose we have another matrix called S12. In S12 matrix, what is ith element? What is the jth element? Ith element represents input port, jth element represents output port. Here 1, 2. This 1 represents input port, 2 is represents output port. 2 represents output port. Suppose I am taking another matrix S31. In this S31, which is input port, which is output port? In S31, suppose we have matrix S31. In S31 matrix, 3 represents input port, 1 represents output port. Using this way, now we will go further. Suppose if we are using 3 by 3 matrix, what are the elements in 3 by 3 matrix? We will get S11, S12, S13. Next, we can call S21, S22, S23. Again, third element is S31, S32, S33. So this is 3 by 3 matrix. Just I am writing beside only. Here S11 we have, S12 we have, S13 we have. Similarly, we can take S21. Next element is S22. Next element is X23. Next S31, S32, S33. Like we are representing 3 by 3 matrix. Here, what are the need of S parameters we have? Next one is what is the need of S parameters. For this S parameter, I am considering one 2-port device. To this 2-port device, I am taking input current I1. To this 2-port device, I am taking the current parameter as I1 across the input. And the current parameter across the output is I2. Similarly, the voltage parameter across the input I am choosing as V1 and the voltage parameter across output is V2. So two-port device is what? The two-port device is S11, S12, S21, S23. S11 two-port devices. First, roughly I will write here, then I will show in the main test. The two-port, what are the two-port devices we have? S11, S12, S21, S22. Same way we can discuss three-port device also. What is the three-port device? The three-port device is S11, S12, S13. Same way S21, S22, S23. What is the third row? We have S31, S32, and S33. So this is three-port device. The previous one which we discussed is two-port device. Using this two-port device, and this is called as S of 2 by 2 matrix. This is called as S of 3 by 3. This matrix is called as S of 3 by 3. This matrix is called as S of 2 by 2 matrix. This is 2 by 2 matrix. This is 3 by 3 matrix. This whole matrix we can represent as ith element as well as jth element. In this ith element is 1, jth element is 2. In S12, what is ith element? Ith element is 1, jth element is 2. In S21, 2 is ith element, j is 1. Same way, we can write for one port and two port network. Next, we will see what is the necessity or what is the need of S matrix. Next, we will see the need of S parameters. To this need of S parameters, I am taking one port. Whatever the port I am considering, it is 2 by 2 port. To this 2 by 2 port, I am concentrating on current parameters as well as voltage parameters. The current parameter which I am taking is I1 and the voltage parameter which I am taking as a V1. Whereas across the output, the current parameter which I am taking is I2 and voltage parameter whatever I am taking is V2. Using this, I am writing different types of parameters. What are the parameters here I am concentrating? The parameters which I am concentrating is first one is H parameter. Second one which I am concentrating is Y parameter. Next parameter which we will discuss is Z parameter. Next parameter is ABCD parameter. So here I am concentrating on 4 types of parameters: H parameter, Y parameter, Z parameter, and ABCD parameter. First, we will see what is H parameter. In H parameter, I am taking the one equation as V1 is equal to H11 times of current I1 plus H12 times of V2. Next, I am taking another current equation I2 equal to H21 times of current I1 plus H22 times of V2. H22 times of V2. Here, what is H? H means hybrid parameter. I1 means input current. I1 current. I2 is the current across the output. V1 is the current across voltage current across the input. V2 is the voltage current across output. Now here what I am doing is using this I am separating voltage parameters as well as H parameters. Here across LHS terms I am writing as V1 I2. This V1 I2 is across LHS terms and hybrid parameters together I am collecting as H11. Another term I am writing as H21. Next, I am writing as H21. Next one is H22. This is hybrid parameters. And other side variables, what we have here, I took across the LHS V1, I2. Here I will take I1 current and V2. Using this, Now what I will do, I will write only h11 parameter. From this h11 parameter equal to what we will take? V1 across the input and V2 across the output. Now what is H11? H11 equal to voltage and current parameters. Collectively you collect V1 by I1. V1 by I1. What is constant here? What is another term left? The another term left is V2. V1 by I1 across V2 equal to 0. Similarly, other term also we have to write. What is the next another term we have? Other term is H21 term. H12 term, H21 term, H22 term. So we will see the other terms. Similarly, we will see the other terms. Here, H parameter. Using the equation I am writing. From this equation, what is H11 I am collecting? From this equation, H11 equal to V1 by I1 across V2 equal to 0. Next, H12. H12 equal to V2 by V2, where I1 equal to 0. Here, this is H12 parameter. How to write H12? H12 is equal to, what is across LHS we have? V1 we have. V1 by V2, which is constant. Current I1 equal to 0. Current I1 equal to 0. Next, third term. What is the third term we have? H21. Now we will write H21 term. From here you take H21 term. H21 is equals to, what is LHS parameter we have? Current parameter I2 by current parameter I2 by I1, which is constant here. Here V2 is constant. Next we have another parameter called H22. H22 equal to I2 by V2, which is connected here. These two are connected. H2 equal to I2 by V2, which is constant. I1 is equals to constant. So these four together is called as H parameters. I will write all these four at one place. Finally, what are the parameters we got for H parameters? The four equations we got for H1, four parameters is H11. H11 equal to V1 by I1. Which is constant here? Current is constant. I2 equal to, first V2 equal to 0. This is for H11. Next parameter, what we have? H12 we have. From the equation, what is H12? H12 is equals to V2, V1 by V2, which is constant here. Here the constant term is I1 equal to 0. Next, the third term we have is H21. From the equation, we can write H21 equal to I2 by I1. Here, what is constant? V2 equal to constant. Next, last term is H22. Here, H22 is equals to, we can write that I2 by V2. I2 by V2, which is constant. I1 equal to 0. So these are called H parameters. Same way we can write Z parameters, admittance parameters, impedance parameters, as well as ABCD parameters. Next, continuation, what we have? Admittance parameters. What are the things we have to consider in admittance parameters? The admittance parameters across input side, I am taking two currents, I1 and I2. Next, admittance parameters is Y11, Y12, Y21, Y22. Here, across LHS, we will take V1 and V2, V1 and U2. Same way, now we have to write Y11, Y12, Y21, Y22. Three parameters we will write. Same way, next is Z parameters. For Z parameters, what are the factors we have to consider? For Z parameters across input side, I am taking V1, V2. Next, here Z admittance impedance parameters are Z11, Z12, Z21, Z22. This is called impedance parameters. Here across RHS we have two current parameters I1 and I2. Same way another parameters is there. The another parameters here is ABCD parameters. Next parameters we will discuss is ABCD parameters. In ABCD parameters, LHS is across V1, I1. And here the parameters I am taking as A, B, C, D. 4 parameters I am taking. And here I am taking across the RHS V2 and minus times of I2. This is Z parameters. So this topic covers the need of S parameters. Next topic we have is scattering matrix formulation. In this scattering matrix formulation, here I am taking N-port junction. What is the meaning of N-port junction? Port means either it is 1 port, 2 port or 3 port. Just now we discussed in 2 port we are representing S11, S12, S21, S22, S21, S22. Similarly, I am writing for N-port junction. The N-port junction, we have how the diagram represents. Here I am taking input to this input while going to the output, to this input to the output. In between, I have ports, entrances. In between, I have entrance. Like this, the connection we have. Here, whatever the voltage entering inside, the voltage entering inside, I am taking as a V1 plus. The voltage leaving outside, I am taking as V1 minus. Next, the voltage across this inside. Whatever the voltage entrance is input, I will take as plus. Output, I will take as minus. Here, the input voltage, whatever is entering, I will take V2 plus. In this, again, one more is exiting outside. Whatever it is exit, I will take V2 minus. V1, V2. Suppose another port I am concentrating. Again, we have entrance as well as we have exit. Here entrance I am taking as V3 plus, exit I am taking as V3 minus. Next I am concentrating another port. Similar way I am concentrating another port. This input I am taking as Vn, nth port plus. If suppose this is exit Vn minus. Suppose if it is entering inside, I am taking this as a Vn plus. So this is the diagram of scattering matrix. Overall, what I want to conclude, output is represented with minus, input is represented with plus. V1 of minus equal to S11 scattering matrix of V1 times of plus. So output matrix equal to the scattering matrix times of input matrix, where this V1 plus represents incident part. V1 plus represents what? V1 plus represents incident. V1 minus represents output. Similarly, I wrote for only one variable S11. Now we will see for nth port. How to represent for nth port? The same way, to represent nth port, I am taking Vn minus. For representing nth port, I am taking Vn minus S of N1 times of V1 plus, where Vn minus is represents for what? Vn minus is represents for the output. V1 plus is represents for the input. S1, N1 is the transmission from line 1. Means this is input port, nth input port across channel 1. This is nth port. N represents nth port. This 1 represents channel 1. 1 represents channel 1. So for the first voltage, how we will write? V1 minus. First voltage, V1 minus equal to S11 of V1 plus. Similarly, I am using for the nth port. For nth port, the output equal to Sn1 plus of V1 plus. Now, overall, all writing collectively together, we will get V1 minus equal to S11, S12, so on up to S1n, nth channel, times of V1 plus. Second, if we choose V2 minus is equal to second channel, second port, S21, S22, next S2 times of n, S2n times of V2 plus. This is representing in matrix format. Similarly, V2 minus this is, similarly, I am taking Vn minus. The Vn minus is represented for nth port, Sn1, Sn2, Sn times of Vn plus. So, final conclusion is representing final conclusion, voltage, output voltage equal to S matrix times of input voltage. Output voltage equal to S matrix times of input voltage. So, this is for what? Scattering matrix formulation. Now, we will see this one in notes. See here, scattering matrix formulation. In scattering matrix formulation, what are the things is covered here? First, the diagram is represent. What is V1 plus here? Input side. V1 minus means the arrow is output, V1 minus. So this combination is for the input, first port. Similarly, for the second port, here it is V2. V2 plus is inside, V2 minus is outside. Similarly, third port. For the third port, V3 plus is inside, V3 minus is outward direction. Similarly, for the nth port, this is inside direction, this is outward direction. So, the diagram represents N-port junction. This diagram represents N-port junction. The reflected wave for the line 1 is represented as V1 minus equal to S11 times of V1 plus. What is S11? S11 is the reflection coefficient or scattering coefficient. Here we will call S11 as the reflection coefficient or scattering coefficient. Similarly, I am writing for Vn minus. Vn minus equal to Sn plus of V1 plus. Overall, collecting this transmission for different ports. Here in the diagram, here I shown only for the 3 ports. How many ports we considered here? Port 1, port 2, port 3 and nth port. Same way, I am collecting all together and writing here. In this, V1 minus, V2 minus, Vn minus. All these are output side. V1 plus, V2 plus, Vn plus. All these are input with scattering matrix. The scattering matrix is S11, S12, S13, so on. So this is the final conclusion of the scattering matrix formulation. Next topic here, what we have is properties of the S matrix. We have here 4 properties of the S matrix. What are the 4 matrix properties of the S matrix? Thus, matrix and its complex conjugate. What are the 4 properties? The scattering matrix and its complex conjugate. Here, complex conjugate I am representing with star. Matrix and its complex conjugate, both together can be treated as identity matrix. If it is 2 by 2, the identity matrix is 1, 0, 0, 1. Suppose if it is 3 by 3 matrix, 1, 0, 0, we know as 3 by 3 matrix. What is 3 by 3 matrix? If it is 3 by 3 matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. So, matrix and complex conjugate matrix, both are equal to identity matrix. This is the first pattern. Any one of the property. What is written here? S matrix is a unitary matrix. Next is S matrix is symmetrical. What is the meaning of symmetrical here? Here I am taking Here we will see the matrix. What is the first one we have? S of Nm is equal to S of Mn. Means the scattering matrix is symmetrical. Scattering matrix is symmetrical. What is the second property here? Scattering matrix S and its complex conjugate. Both are equal to identity matrix. Here, suppose if it is 2 by 2 matrix, where is next page in this? Next page. Here, suppose 2 by 2 scattering matrix 1, 0, 0, 1. Suppose if it is 3 by 3 scattering matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So matrix and its complex conjugate is identity S, S star equal to identity. This is one of the property. Next property is what? Suppose I am taking one scattering matrix S with NR, two variables here, NR and S star, complex conjugate. If complex conjugate of NS or else S of NS, S star, complex conjugate. If I take complex conjugate of NS, then it is equal to 1. But I am taking S of NS. Another one I am taking S star N of another variable. Here the variable I am taking S. Here I am taking the variable R. In such cases, we will write this one as 0. This is one of the formula. Next, for the lossless junction. Here the lossless junction is represented as sigma n is equals to 1 to n. The loss junction is S equal to n equal to 1 to n. S of ni. Another one I am taking complex conjugate S star of ni. Both are equal to 1. This is for lossless junction. So these are the 4 properties of the S matrix, which is important for 5 marks question. This may cover under, means previous years, these are coming as a 5 marks question. So finally, what are the properties we have? Symmetrical property, it holds good. What are the symmetrical property? S star of Nm is equal to S of Nm. First property. Second property is scattering matrix and its complex conjugate is equal to identity matrix. Next, another is for lossless junction. What we have? For lossless junction, sigma n is equals to 1 to n. For lossless junction, sigma n equal to 1 to n. S of ni. Another one, what we have? S of ni star. Both are equal to 1. Another, what we have? S of ns, S star, nr. In this case, this is 0, where S is not equal to R. All these are the conditions is for what? Properties of the S matrix. Next, we have scattering matrix for two-port junction. The scattering matrix for the two-port junction, we have to calculate here S11, S12, S21, and S22. 4 parameters we have to calculate. First, we will see the diagram here. It is two-port junction we have. Similarly, whatever I said previously, this is input side. This is two-port network. This two-port device this is two-port device. Whatever is going inside arrow. Next, output is represented with outside arrow. Here also inside input is represented with inside arrow, output is represented with outside arrow. Here inside is always remember plus symbol, outside is represented with minus symbol. Inside is represented with plus symbol, outside is represented with minus symbol. For this, I am writing two equations. The two equations here I am choosing as V1 minus. Here we are discussing scattering matrix for two-port junction. Here input is represented with plus sign. Here input is represented with plus and output is represented with minus across the input side. Again from another port, here I am taking two ports. This part is port 1, this part is port 2. Again in the port input side is represented with plus, output is represented with minus. Now using this incident wave from input side and as well as output side, I am forming two equations. What are the two basic equations we discussed previous? Output is represented with minus. Always remember, LHS is represented with minus, RHS is represented with plus here. So the first variable V1 minus equal to S11 times of V1 plus S12 times of V2 plus. Similarly, second voltage equation, V2 minus equal to S21 times of V1 plus S22 times of V2 plus. Using this, now I am writing LHS parameters across LHS side in the next equation. In the next equation, what I am getting? V1 minus and V2 minus. And what are the S parameters we have here? The S parameters are S11, S12, S21, S22. And the voltage parameters, what we have in this equation, the voltage parameter, one we have is V1 plus, another one we have V2 plus. Two voltage parameters we have. So final conclusion using this one, I'm writing as V minus equal to S parameter of V plus. V minus equal to S parameters of V minus. Here from equation 1, I want to write S11. How we will write S11 from this? S11 equal to from this, I want to write S11. From this, I want to write which one I have to cover from these two equations. I want to write S11. How we will write S11 from this? From this equation, I will write now S11. What is S11? Here I am writing S11. What we will get S11? What we have in the LHS? We have V1 minus. V1 minus by V1 plus. Which is constant? V2 equal to 0. This is S111 parameter. Same way, now I want to write S12 parameter. Now what is S12 parameter? Using this S12 parameter. S12 parameter. From S12 parameter, I am writing V1 minus. S12 parameter, I am writing as V1 minus by, from the equation, I am writing S12 equal to V1 minus by V2 plus. Similarly, S21 from the above equation. S21 I am writing as V2 minus by V1 plus. Next, from equation 4.27 in the textbook or from previously which we discussed, S22 equal to what I am writing? S22 equal to V2 minus by V2 plus. These are the four scattering matrices I am writing. The four scattering matrices here we calculated S11, S12, S21 and S22. Now this is a 2 by 2 matrix. To this 2 by 2 matrix, I am writing its complex conjugate form. What is 2 by 2 matrix here? The 2 by 2 matrix is S11. This is the 2 by 2 matrix I am writing. What is the 2 by 2 matrix? S11, S12, S21, S22. To this one, I am taking complex conjugate and multiplying with identity matrix. Now I will show this solution on the what? Yeah. We will see the scattering after writing S11, S21, S22, and S23. Here I am taking scattering matrix. The scattering matrix which I am taking is S11, S12, S21, and S22. To this matrix, I am also taking identity matrix. What is the identity matrix for this one? Complex conjugate form. Then you multiply identity matrix. S11 star, S12 star, next S21 star, next S22 star. This one I am multiplying with identity matrix. Here the identity matrix which I am taking is 1001. Now what I will do? Here this one is row 1, column 1. So take three conditions. What are the three conditions? Matrix multiplication we have to do. What are the three conditions on matrix multiplication? I am doing row 1, column 1 multiplication. Next is row 2, column 2 multiplication. Next is row 3, column 3 multiplication. Matrix multiplication I am doing. Row 1, column 1. What is row 1 here? S11, S11 star, S12, S21 star is equals to 1. After doing multiplication, one row, one column. After doing R1, C1, what I will get? S11, S11 star plus S12, S12 star is equal to 1. This is the condition for which one? Row 1, column 1. Similarly, I am doing another matrix multiplication is row 2, column 2. If we do row 2, column 2, I will get S22, S22 star. Next, S12, S12 star is equal to 1. Next, I am multiplying row 3, column 3. This is row 1, column 1. This is row 2, column 2. Next, I am taking row 3, column 3. If I take row 3, column 3, I will get S11, S12 star plus S12 plus S22 star. This one equal to 0. Treat this one as equation number 1. Treat this as equation number 2. Treat this as equation number 3. Using these equations, using first equation, S11, S11 star, I am treating as a S11 square. S12, S12 star, this one. S11, S1 star, S12, S12 star. This one I am writing as S11 square plus S12 square. Here we took row 1, column 1, row 2, column 2, and row 3, column 3. Now from here, from first equation, I am writing S11 square plus S12 square here. S12 square, how we, first you take third equation, what you have? Third equation, what we have in third equation? Third equation we have S11, S12 is equals to minus of S12 and S22. This is from third equation we got. From second equation, here I am writing S12 equal to S21. Here I am writing from the first equation, S11 modulus square is equal to S22 square. Next, another one I am taking as S12. I am taking next one is S12. Here what we are getting S12, S12 square from equation 1, S12 square is equals to under root of 1 minus S11 square. This one I am writing in terms of theta. If we write in terms of theta, what we will get? S11 is equals to modulus of S11 times of e power j times of theta 1. J is imaginary part. Here I will show the derivation part, what were explained. See here. R1 C1, what we got? R1 C1, S11, S1 star, S12, S21 star, row 1, column 1. Next to row 2, column 2. What is row 2 here? Row 2 is S21, S22. What is column 2? Here column 2 is S1 star, S2 star. These are multiplied and we got this equation. Next, from R1 C1. From R1 C1, I am writing S11 modulus square plus S12 square is equals to 1. Up to here, S11 square plus S12 square equal to 1. Next, from equation R2C2, what I am writing? S21 equal to S12. Remember one condition, S12 equal to S21. Based on that, here I am writing, this is the equation for R2C2. What is R2C2 equation? S12 square plus S22 square equal to 1. Using these two equations, I am simplifying that S11 equal to S22. Next, another condition. So, we did 3. What are the 3 we did? 3 multiplication I did. What are the 3 multiplication? Row 1, column 1 is multiplied. Next we multiplied row 2, column 2 multiplied. Next we multiplied row 3, column 3. Not only this, we had to do another multiplication. What is that another multiplication? The other multiplication is row 1, column 2. 4 combinations totally we are doing. Row 1, column 2, what we have? Row 1, S11, S12 is the row. And column 2, what is the column 2? This one, S12 star, S2 star. These two are multiplying. So we are getting this equation. What is the equation after multiplication R1 and C2? After multiplying R1, C2, we are getting this equation. Using this, I am representing S12 equal to under root of 1 minus S11 square. Here, I am writing in terms of theta. If I write in terms of theta, what we can write S11 equal to S modulus of S11 times of e power j theta 1. Similarly, S22 equal to modulus of S22 e power j theta 2. Here, S12. What is theta here? Theta represents theta 1 plus theta 2 by 2. The theta represents theta 1 plus theta 2 by 2. So, finally, what we discussed in this topic, the overview of this topic is totally we discussed from this topic. What is the topic which we discussed? We discussed the topic scattering matrix for two-port junction. In this two-port junction, I calculated S11, I calculated S12, next calculation of S21, next calculation of S22. These four parameters is calculated. Again, scattering complex conjugate is equal to identity matrix. Using this, wrote the both sides as well as calculated R1 C1 multiplication, matrix multiplication of R1 C1, matrix multiplication of R2 C2, next matrix multiplication of R3 C3, next matrix multiplication of R1 C2. Using this combination, I calculated the values of S11, S12 as well as theta. So this is the topic of which we discussed. What we discussed, ma? This is the topic of scattering matrix of two-port junctions. After two-port junction, the next topic we have shunt element transmission line as well as series element of the transmission line. In this shunt element and series element, what we are doing in the shunt element and series element? In shunt element, I am taking the impedance. Here the impedance is represented with Z of S. Series, shunt element. Shunt element. Z is impedance, S is shunt element. To this one, again I am connecting input side as well as output side. To this ZS, two sides I am choosing. Whatever the current this side is flowing as I am treating the current I1. Whatever the current other side flowing is, I am treating as a current I2. To these currents, across the impedance Z0, here output impedance I am taking Z0. Across two sides, I am taking output impedance Z0. This side, whatever the impedance I am getting, this is called as Z1. Here, whatever I am input, here this side I am getting as Z2. So, Z, what is Z here? Z is impedance. Shunt element is S. Two currents across two sides. The current whichever is entering is I1. Here the current is flowing this way is also treating as I. So here I am calculating some coefficients using Y parameters which we discussed previously. So here the parameters, Y parameters I am writing as S11 equal to Y0 minus Yi by Y0 plus Yi. Y0 minus Yi by Y0 plus Yi. Here, what is Yi? Yi equal to Y0 plus Ys. Substitute Yi. What do we have Yi? Yi equal to Y0 plus Ys. Substitute this Yi equal to Y0 plus Ys in this equation. Substitute this one in S11. After substituting, you will get S11 value. Here we will see the substitution. Next page. Next page. Substituting Yi value. After substituting Yi value, what I got? Y0 minus Y0. Because minus Yi we have. Minus Ys by Y0. What is Yi? Y0 plus Ys. These will cancel. So we will get output of S11. S11 equal to minus times of Ys by 2 times of Y0 plus Ys. This is the parameter of S11. Similarly, we have to calculate S22. As it is a symmetrical junction, S11 equal to S22. For symmetrical junction, what we have? S11 equal to S22. So, same value we will get for S22. S11 is equals to S22 equal to same value we will get. What is the value we got? Minus Ys by 2 Y0 plus Ys. Now, next I am calculating S12, S21. So, 4 parameters we have to calculate. S11, S22, S21 and S22. Now I am calculating the what next we have to calculate. We have to calculate S12. What is the formula of S12? We have S12 is equals to under root of 1 minus S11 square. Next, we have another formula S21. S21 equal to 1 plus S11. Now, substitute this, we will get. If you get S21 value, we can also write S12 value. Either you can use this formula or this formula. S12 equal to under root of 1 minus S11 square, or we can represent with another formula. The another formula for S21 equal to 1 plus S11. Now we will substitute 1 plus S11. 1 plus, what is S11 we got? Minus Ys by 2 times of Y0 plus Ys. This which I got, this is the value of S11. Take LCM and calculate the final value. Final value, what we will get here? 2 Y0 plus Ys minus ys by 2y0 plus ys. Using this, ys minus ys is cancelled. What we will get? 2y0 by 2y0 plus ys. So this is the value of S11 S21, S12 or S21. This is the value of S21 or S12. So we calculated four values. What are the four values we calculated for shunt impedance? For shunt impedance, I calculated four values, S11 as well as S12. Next calculated S21 and calculated S22. Now similar way, now we will see for the series element, shunt element in 3D transmission. So after calculating the four, final S matrix format we have to represent. What is S11? I got minus ys by 2y0 plus ys. First element. Second element is 2y0 by 2y0 plus ys. Second element. Third element 2y0 by 2y0 plus ys. Third element. Next fourth element is minus ys by 2y0 plus ys. So this is the scattering matrix for which one we discussed. The whole matrix is scattering matrix for shunt element. Scattering matrix for shunt element we calculated. Similarly, we will calculate scattering matrix for series element. So what is the difference between the shunt element and series element? In shunt element diagram, the impedance is connected in series. Previous whatever just now we discussed, here impedance is connected in serial format. So this diagram is represents shunt element. And now this diagram, whatever I am drawing, Z of S. Here I connected impedance in parallel method. This is the difference between the shunt elements and series element. The first figure called as shunt element. The second figure is called as series element. In series element, the impedance ZS is connected in parallel, whereas their ZX is connected in series. Again, here also we are calculating V1, V2. Here also we are calculating four parameters. What are the four parameters we are calculating? Here we are calculating four parameters. The four parameters are S11, S12, S21, S22. Here four parameters is calculated. And the input side I am treating as a plus. Remember, this is very, very important point. Input side is treated as plus. Output side is represented as minus. Here I am taking one matrix. To this matrix, one impedance parameter ZS is chosen. To this ZS, input side is plus V1 plus. Output side I am choosing as V1 minus. This side, input side I am choosing as V2 plus. Output side I am choosing as V2 minus. Again, to these diagrams, I will calculate S11. Now we will write one by one. What we will get S11? S11 equal to output minus input. Output is represented with minus. Input is represented with plus. Here, the formula we will write Zi minus Z1 by Zi plus Z1, where I am choosing Zi is equal to Z2 plus Zs. Substitute Zi equal to Z2 plus Z2, where in this we have to substitute. What is the formula for S11? S11 equal to Zi minus Z1. This is I. Zi minus Z1 by Zi plus Z1. In this, I am substituting the value of Zi equal to Z2 plus Zs. After substitution, I got S11. After simplification, what we got? S11 S11 equal to Z2 minus Z1 plus ZS by Z2 plus Z1 plus ZS. As we know that S11 equal to S12. So, same formula can be written for what? S22. Same formula can be written for S22 with small change in polarities. What are the small change in polarities here with Z2 minus Z1? Z1 minus Z2. Here Z1 we have minus sign. Here I am choosing plus sign. Z1 minus Z2 plus ZS by Z1 plus Z2 plus ZS. This is second parameter. Similarly, we have to calculate remaining three parameters. What are the remaining parameters? Here, here. What is S11 in this diagram? Impedance is connected. First point is impedance is connected parallel. Voltage is plus means inside. If voltage is minus means this is outside. Next here V2 plus means inside voltage. V2 minus means outside voltage. All these voltages are called transmission voltages. Next S11 equal to output by input. Output is represented with minus sign. Input is represented with plus sign. Here I am calculating S11, first parameter. What is S11? Zi minus Z1 by Zi plus Z1. Here I am substituting Zi value. What is Zi value? Zi value equal to Z2 plus ZS is substituted. After substitution, we got S1 value as well as S22 value. What is the difference between S1 and S22 value? In S11 value, Z2 minus Z1 is written, whereas in S22, Z1 minus Z2 is written. This is S11 and S12 value. Similarly, calculated current parameters. Remaining, what are the two remaining things we have to calculate? The remaining two things which we have to calculate is S12 and S21. This is S11 parameter. This is S2 parameter. Now, which is left? S12 parameter is left. This is S21 parameter is. Then how to calculate these two parameters means, first we have to take the simple voltage. What is the simple voltage? Here I am choosing the simple voltage writing in terms of input and output. V1 equal to V1 plus V1 minus. Divide both sides with V1 plus. Divide both sides with V1 plus. Multiply and divided by V1 plus. Here, second term only I am multiplying and dividing. Multiply and dividing with only second term. After multiplying and dividing with second term and making V1 plus common. After making V1 plus common, I got V1 equal to V1 plus times of 1 plus S11. I got V1 equal to V1 plus 1 plus S11. Similarly, I am writing in terms of current equation. After writing current equation, the final we will get as two ways we can write. S21 and S1 equal V2 minus by V1 plus, or impedance in terms of impedance parameters. V2 minus, finally, this is mentioned in terms of impedance. Z2 by Z1 whole to the power of 1 by 2 times of 1 minus S11. So, if we substitute, we will get the final term as 2 under root of Z1, Z2 by Z1 plus Z2 plus ZS. This is the term which we will discuss is S matrix for series element. So, final conclusion in this topic is impedance we are calculating both in series and shunt element. In shunt element, impedance is connected in series. In series element, impedance is connected in parallel and we calculated 4 parameters. The 4 parameters is S11, S12, S21 and S22. 4 parameters is calculated. Next, we will discuss about T's. Next, we will discuss very important topic is matrices for E-plane, H-plane and magic tape, which we can guess, I mean, in previous years, this is coming as a essay questions. 3 topics we have. What are the 3 essay questions we can guess? One is E-plane T. Every year, these are repeating. Second one, which we can guess is H-plane T. The next one, which we will discuss is magic T. In this first, today we will see E-plane T. In this E-plane T, input port, we are using 3 ports. Input port is represented with port 1. Here, port 2 is represented as output port. Then this port 3 works as a output port only. So, out of 3 ports, port 1 is input, port 2 is output, port 3 is also output. Suppose I am taking input across port 3, the second figure, this figure. What is this figure represents? In second figure, port 3 is input port, port 1 is output port, next port 2 is also output port. So if first one is input. If first port is input, second port is acts as an output port, as well as third port is acts as an output port. This is one option. Suppose second port is input. If second port is input, first port acts as an output port, as well as third port is acts as a output port. This one in diagrammatic way of representation of these ports. The diagrammatic representation of these ports is suppose like this, the diagram we have. Input port. Port 1 is in. Port 1 is input. If 1 is input, what about 2 and 3? 2 and 3 both are output way of representation. Output port. This one is out. This one is out. Even these are out. This is in output and output. This is called one type. Another type, this one. Now here I am taking input across port 2. Port 2 is input. If port 2 is input, what about port 1? Port 1 is output. If port 1 is output, the lines is coming like this. And this one is also can be treated as out only. This can also treated as out only. Now, how to represent this one in the diagrammatic format? Here, rough diagram. Suppose this is port 1. This is port 1. The other side is port 2. The other side is port 2. To this port, like this, I am taking another port. This port, I am calling this port as port 3. E-plane T. This is called as a E-plane T. To the wall, another piece of waveguide is attached. This is a waveguide of two ends of the waveguide. To these two ends of the waveguide, another waveguide is attached. One side I am treating it as a port 1. This side I am treating as a port 2. This part is port 3. This is combination is called as a collinear amps. Collinear amps. This arms is called as collinear arms. This is called as collinear arms. Now, to this one, another way of representation is also there. The other way of representation is, suppose this is port 3 and this side and whatever like this diagram is there. This part is port 3. This part is port 1. This part is port 2. This is equivalent E-plane diagram. What is this diagram represents? This diagram represents E-plane diagram. This is the diagram of E-plane. Now, we will see the derivation of E-plane matrix for this derivation part. In derivation part of E-plane T, here I am considering 3 by 3 matrix. What is the 3 by 3 matrix we have? S11, S12, S13. Next, S21, S22, S23. Next one, S times of 31, S times of 32, S times of 33. This is 3 by 3 matrix. To this 3 by 3 matrix, I am applying some conditions. What are the conditions I am taking here is S23 is equal to minus of S13. The next condition is I am taking as S of 33 equal to 0. The next condition which I am implementing is S12 equal to S21. Next condition is S13 equal to S31. The next conditions are S23 is equal to S times of 32. All these conditions substitute in 3 by 3 matrix. After substituting all these conditions in 3 by 3 matrix, what are the matrix we will get? The matrix which available is S11, S12, S13. S12 in place of S23, I am substituting minus S13. Minus S13. S22 is writing as it is. Next, third matrix. S31 can be written as S13. S31 can be written as S13. Next, S32 or S23, both are equal to minus S13. Another matrix, S33 equal to 0. Take this matrix, apply complex conjugate. After applying complex conjugate, equate to identity matrix. We have 3 tasks. This is the matrix. Its complex conjugate means what we have to write? Stars. Complex conjugate. To this, apply stars. So, one matrix, its complex conjugate matrix, equate to identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 0. Equate to identity matrix. After equating, again we have to follow few conditions. What are the conditions we have to follow? Multiply row 1 with column 1. Multiply row 2 with column 2. Multiply row 3 with column 3. Another condition, multiply row 3 with column 1. These 4 conditions we have to apply for which one? Scattering matrix S as well as casting matrix of S star is equal to identity matrix. After applying 4 conditions, we will get some values. Again, those values you substitute in the matrix which E-plane is derived. Now we will see that one. E plenty. In this E plenty, what is the matrix after substituting the conditions? We got scattering matrix. After substituting the conditions. After substituting the condition, this is the matrix. What is the matrix we got? S11, S12, S13. Second row. What is second row? S12, S22 minus S13. What is the third one? Third row? S13 minus S13, 0. And take its complex conjugate form. Same matrix in terms of stars is written. This is called as complex conjugate of the matrix, equated to the identity matrix. After that, what you have to do? Here, what is row 1? Row 1, S11, S12, S13. This has to be multiplied with column 1. What is column 1? S11 star, S12 star, S13 star. Row 1, column 1 is multiplied. See, S11, S11 star. First element. Next, second element. Next, third element. Multiplied and I equal to 1. Next is row 2, column 2. What is row 2 here? What is row 2? Row 2 equal to S12, S22 minus S13. Row 2 is equal to S11, S11, S12, S22 minus S3. This has to multiply with column 2. What is column 2? This is column 2. These two are multiplied. This is mentioned in row 2, column 2. Row 3, column 3, row 4, R3, C1. Same way we multiplied. And making this in terms of modulus. The same these equations. The same these three equations is written in terms of 1, 2, 3. Next. From R3, C3, what we got? Same is repeated. S13, S13. 2 times is repeated. In third equation, 2 times is repeated. So I am writing as 2 times of S13 whole square equal to 1. From this, I calculated S13. What is S13 I got? S13 equal to 1 by root 2. This S13 equal to 1 by root 2. Next, R3, C1. In R3, C1, which is common in both? S13 is common. In R3C1, S13 is common. So here we got S13 some value, means S13 is not equal to 0. So finally showing here as S11 equal to S12. S11 equal to S12. Now substitute equation 5 in equation 1. What is equation 5? Equation 5 is S11 equal to S12. Substituting in equation 1 and finally I calculated values and written in this matrix. So this is final matrix. This matrix is called as E-plane T. So in today's topic, we discussed about E-plane T, which we can expect as one essay question. And other topics we discussed is need of the scattering matrix, need of the S parameter. What is matrix we discussed? What is S parameters? Scattering matrix formulation is completed and scattering matrix for two-port junction as well as how this impedance is connected in series as well as shunt element.